Hi guys, in this video we want to convert this galvanometer into an ammeter that can measure a current of up to 2 ampere. That is what the question is saying. That design a shunt resistance whose value can convert this galvanometer into an ammeter that can measure a current of up to 2 ampere. So we are trying to measure a current of 2 ampere. Let's call the current I. So we want a current of 2 ampere to flow through this circuit and being measured by this galvanometer of 20 milliampere and resistance of 5 ohms. To do that, we need to connect what we call a shunt resistance across this galvanometer. This is what I mean. You connect a resistance or a resistor known as the shunt in parallel to the galvanometer, and it is the value of this shunt that we are calculating, the shunt resistance. If you can get the value of the shunt resistance correctly, it will be able to measure a current of 2 ampere flowing through this galvanometer. Now, how do we calculate for R, or how do we design for R? That's what we are looking at. If you do not understand why we are connecting a shunt like this, then you need to watch my previous video. The link to the video is in the comment section. There you will understand why we are making this connection across the galvanometer. Now you agree with me that when this current of 2 ampere flows up to this point, we call it a node, it is going to split. Most of them will flow through this shunt, while the remaining will flow through this galvanometer. Of course, we want 20 to flow through this galvanometer because that is the rating of the galvanometer. So we can say that the current that will flow through this shunt be what? I shunt, ISH, to represent the current that is flowing through this shunt. And let the one flowing through the galvanometer be called IG, and of course it is 20. So you can see that at this point there is a split of the 2 ampere current between IG and I shunt. Now, what happens? We want to know the value of I shunt. Take note, if 2 ampere flows to this point and 20 milliampere goes this way, of course it will be easy to tell the I shunt. So we can write a formula that says the shunt current I shunt will be equal to this current coming in minus this current going out. So we have I minus IG. Of course, it makes sense. For this current to get to this point and split between this and this, it means the sum of this IG plus ISH or I shunt should give us 2 ampere. So to find I shunt, we need to subtract IG from I. This is the equation that does that, and it is known as the Kirchhoff's current law, that says that the algebraic sum of the current R flowing into a node is equal to 0. But that is a story for another day. Now let's put the values. I shunt will be equal to I is 2 minus IG is 20 milliampere. If we convert it to ampere by dividing 20 by 1000, we're going to get 0.02. So that 2 minus 0.02 becomes 1.98 ampere. Now we know the current through the shunt resistor as 1.98 ampere. Now let's investigate another thing. When current flows through a resistor, a voltage is dropped across the resistor. What it means is that this 20 milliampere current that flows through the galvanometer of resistance 5 ohms will drop a voltage across this 5 ohm resistor. Similarly, this shunt current flowing across this resistor will also drop a voltage across this resistor. The beautiful thing here is that the galvanometer and this resistor, they are connected across the same point. What it means is that the voltage that is dropped across this galvanometer is definitely the same voltage that will be dropped across the shunt because they are parallel connection. So let's call the nodes A, B, these 2 points that is connected to the galvanometer as well as the shunt. Let's call it AB. And let's call that voltage that will be appearing across these 2 points VAB. In other words, we are saying VAB is equal to the voltage that will be dropped across the shunt, and is also equal to the voltage that will be dropped across the galvanometer. So we can make a statement that VAB is equal to the voltage across the shunt, and is also equal to the voltage across the galvanometer. Of course, the formula for the voltage is simple. V equals to IR according to Ohm's law. So for the shunt, V will be equals to I shunt times R, and that will be equal to, for the galvanometer, the voltage will be equals to IG RG. We are looking for R, so to make it subject to the formula, we divide both sides by I shunt. so that R becomes IGRG all over I shunt. Putting the values, we have 0.02 for IG. Remember to convert it to ampere by dividing by with 1000 or by 1000 times 5, the resistance of the galvanometer, divided by 1.98, the current flowing through the shunt. And this will give us a resistance value of 0.05 ohms. So you can see that the shunt resistance is very small, 0.05 ohms, so that it can take a very large amount of the 2 ampere up to 1.98 and allow just 0.02 to flow through the galvanometer for a full-scale depletion of the measurement of the current of 2 ampere. I hope this was clear enough and you understood it. To get a better understanding of this, you might want to watch my previous video, whose link is in the comment section. In the meantime, try this simple one. Using the same galvanometer above, using this same galvanometer of 20 milliampere and 5 ohms, could you please design a shunt that can measure up to 4 ampere? That is what the question is saying. Please put your answer in the comment section and I will be there waiting for you. Thank you very much for watching this video. Continue supporting Knowledge Base and see you in our next video.